So now I'm going to discuss GATE 2023 Electronics Communication Engineering Stream Mathematics questions, Engineering Mathematics questions. So the question is the rate of increase of a scalar field f of x comma y comma z is equal to xyz in the direction v bar is equal to 2 comma 1 comma 2 at a point 0 comma 2 comma 1 is four options ABCD given. This is from vector calculus topic. Subtopic is vector differentiation, directional derivative, etc. The solution is rate of increase of a scalar field in the given direction is always nothing but rate of change of phi in the given direction. Rate means automatically change. So this is the derivative in the given direction. Derivative of f in the given direction, which is also called directional derivative. So first of all, we have to find del f for the given scalar field. F is a function of three variables, so del f is a 3D vector. I cap dou f by dou x plus j cap dou f by dou y plus k cap dou f by dou z. Now, with respect to x, partial means yz constant. With respect to y, xz constant. With respect to z, partial xy constant. So you will be getting I cap into yz plus j cap into zx, k cap into xy. So with respect to z derivative 1, with respect to y derivative 1, with respect to x derivative 1. Now they are asking at a point 0, 2, 1. Let us denote that point P 0, 2, 1. So substitute x0, y2, z1 in this del f. That is gradient f or del f. So y value 2, z value 1, 2 I cap, x value 0. The last two terms absent. So you will be getting only in the direction of x-axis only, this del f vector. Okay. Now, given direction. Direction means vector. Directed line segment is, this is v. V means I can take v bar also to understand in a better way. So vector can be represented in a 3D point representation or just like 2i cap, j cap, k cap, like that. 2i cap plus j cap plus 2k cap. So find the unit vector in the given direction. Implies e cap is equal to v bar. So instead of this v, I have taken v bar. So this is meaning that point 2 comma 1 comma, that is the direction 2 comma 1 comma 2. So v bar by mod v bar. So 2i cap plus j cap plus 2k cap divided by square root of 2 square plus 1 square plus 2 square, or first find del v bar and then write e cap vector. So square root of 9, 3, 1 upon 3 multiplied by 2i cap plus j cap plus 2k cap. So this is easy question 2023. Okay. Now, therefore, required directional derivative, or what they ask directly, required rate of increase. Required rate of increase. That means the rate of increase of a scalar field f in the direction v is equal to 2 comma 1 comma 2. Instead of writing this sentence, I can say required rate of increase. Okay. So this is e cap dot del f, which is nothing but directional derivative procedure. which is nothing but exactly directional derivative they asked. So dot product, you know that 1 by 3 into sum of the products of the corresponding coefficients of I, j, k respectively. So 2 into 2 remaining in del f j k cap absent. So that products become 0. Dot product becomes 0. So final dot product is 4 by 3. Any option? Okay. Accordingly, the answer is option B. Okay. So this is the key point. Given direction. So we have to find unit vector in the given direction. This is direction. I have denoted the direction by V bar, and this is the final required rate of increase. Okay, you know del f. This is 3D. Function is a 3 variables. So accordingly, the option is B. This is the end of the question. Next. The question is, let omega power 4 is equal to 16j, or we can read w power 4 is equal to 16j. It's not omega, better to say w. Which of the following cannot be a value of w? Four options A, B, C, D given. So this is from engineering mathematics, from the topic complex variables, subtopic basics. Now solution. Okay. Given w power 4 is equal to 16j. Okay. Implies w is equal to 16j whole power 1 by 4. J is imaginary number. So when we want to find square root, cube roots, nth roots of a complex number where j is a complex number which is purely imaginary, this 4 will go to right side, become 1/4, that is 4th roots of 16j. So first of all, two steps procedure. One step is express this 16j express this 16j as polar form, and then in general form, polar coordinates. Okay, modular amplitude form in general form, that is adding 2k pi. Then proceed finding nth roots of unity by De Moivre's theorem. You will be getting 4 values for w. So this I can write just like I is nothing but e power I pi by 2, cos pi by 2 plus I sin pi by 2 is nothing but I only. So j is can be written as 16 into cos pi by 2 plus j times sin pi by 2. Sin 91, cos 90, 0. This is modulo amplitude form where 16j modulus is 16. That amplitude theta is pi by 2. Okay. Next step. Adding 2k pi. Cos pi by 2 plus 2k pi plus j sin pi by 2 plus 2k pi. Okay. We know that cos theta plus j sin theta, I sin theta is e power I theta. That is Euler's representation. So can I write it directly like this? E to the power j times pi by 2 plus 2k pi. Okay. Since e power I theta is equal to cos theta plus I sin theta. Here 2k pi means multiples of 2 pi, adding or subtracting won't change in the position, but theta value are many, infinitely many argument value sin theta. So therefore this omega, that is w, is equal to 16 e to the power j times pi by 2 plus 2k pi bracket close, and main bracket to the power 1 by 4. 16, fourth root of 16 is by 2. Now this is remaining term a power m whole power n, nothing but a power mn, e power j times this 1 by 4 multiplied with pi by 2 plus 2k pi along with j. Okay, so this is pi by 8 plus k pi by 2. What are k values? Because that power 4 indicates 4 values for w. So starts from 0, 1, 2, 3. This is n minus 1. So this looks like I can denote nth roots of a complex number 16j. So this 3 is nothing but n minus 1. So refer that procedure. K value 0 to n minus 1. Next. So giving 1 by 1 values here. K is equal to 0 gives W is equal to 2 times e power j pi by 8. E power j pi by 8. Yes, this is already there. They are asking cannot be a value. Okay. Now, k is equal to 1 gives, putting k is equal to 1. So, pi by 2 plus pi by 8. 2 into e power j into pi by 8 plus pi by 2. Pi by 2 can be written as 4 pi by 8, or you can take LCM. So this is simplifies to 2 into e to the power j 5 pi by 8. Okay, so this is also there in the option. Next, k is equal to 2 gives w is equal to 2 into e to the power j into pi by 8 plus pi. So pi by 8 plus pi simplifies to 7 pi by 8 by taking LCM 8. 2 into e to the power j into 7 pi by 8. Okay. Not 7, 9 pi by 8. Okay. 9 pi by 8. Next, this is also in their option. K is equal to 3 gives W is equal to, here put K is equal to 3, 2 times e to the power j into pi by 8 plus 3 pi by 2. LCM is 8. So 1 pi plus 4 into 3, 12, 12 plus 1, 13 pi. Finally simplifies to 13 pi by 8. Okay. So this is not in options. Okay. Therefore, W is equal to 2 into 13 pi by 8. Okay. Is not in option. The first three are in options. And A option we didn't get. We got in place of 2 pi by 8, 13 pi by 8. Okay. W is equal to 2 times e to the power j times 2 pi by 8 is not a value of, okay, is not a value. Or you can write 2 into e power j into 2 pi by 8 is not a value of W. Okay. So accordingly, A is the option. This is the answer. So this is the main point. Cos pi by 2 plus sin pi by 2. Okay. I can write here since j is equal to e power j into pi by 2. You can begin with like this also, e power j pi by 2, or we are well remembered these cos 90 sin 90. You can write, you can start like this also. And the next key point is this one, adding 2k pi. After this one. Okay. So finally the answer is option A. This is end of the question. The question is the value of the contour integral over c z plus 2 divided by z square plus 2z plus 2 dz, where the contour c is set of all z such that mod z plus 1 minus 3 by 2 j mod is equal to 1 taken in the counterclockwise direction is. This is from engineering mathematics from the topic complex variables, subtopic complex integration. Using, you can evaluate the integral by Cauchy's integral formula or Cauchy's residue theorem. Here the curve is a circle having center is minus 1 plus 3 by 2 j and radius is 1, comparing with mod z minus a is equal to r value 1, radius, center is minus 1 plus 3 by 2 j, where j is imaginary part. So solution, curve C is, that is curve equation is mod z minus of 1 plus minus 1 plus 3 by 2 j is equal to 1. Center at minus 1 plus 3 by 2 j and the radius is equal to 1. So this is a circle. First of all, comparing with circle equation in complex form, mod z minus complex coordinates. Okay, mod z minus a is equal to r. Now, so I want to evaluate by residue theorem. Before that, find the poles of the, find the singular points of the integrand. This is our integrand f of z. Okay. Now, denominator. What is denominator? Z square plus 2z plus 2 is equal to 0, which is a quadratic equation whose roots are obtained by either factorization or minus b plus or minus root over b square minus 4ac by 2a. You will be getting minus 2 plus or minus root over b square minus 4ac by 2a. 4 minus 8 is minus 4. Root minus 4 is 2i. So 2 is common and then cancelled. In place of I can write j because j is denoted by here imaginary part divided by 2, which implies z is equal to minus 1 plus j comma minus 1 minus j. Okay, are the singular points of the integrand. So I am using Cauchy's integral formula. We can evaluate by Cauchy's residue theorem also. These singular points are also called poles of order 1. These two singular points obtained from equating denominator to 0. The denominator having whole power 1. The power of the denominator factor is 1. So that's why each singular point is a pole of order 1, because numerator, denominator, finite powers of z. Okay. So now check whether these points inside or outside, or at least exactly one point inside, like that. So if I put minus 1 plus j in this, okay, j minus 3 by 2 is minus of j, mod minus of plus 1, mod j value 1, so less than 1. And if I put minus 1 minus j, this is greater than 1. So only z is equal to minus 1 plus j lies inside C. Okay, you can draw the circle diagram and you can locate these points and check that whether inside, outside, or alternative procedure. Okay, for z is equal to minus 1 plus g implies the curve equation. Substitute this z point in the curve equation. Check whether LHS less than RHS. So z plus 1 minus 3 by 2j simplifies to minus 1 plus j plus 1 minus 3 by 2j So this is j minus 3 by 2j is minus 1 by 2j mod nothing but half, which is less than 1. This is RHS of the equation. This half is LHS of the equation. Whenever LHS less than RHS, such a singular point lies inside. Now you can check this is outside. This point lies outside C. Just like here, you can show that. Okay. So this is center, radius. Okay. These are the two singular points. This is only inside. Now, therefore, we have to write this integral as standard form of Cauchy's integral formula, that is f of z by z minus a, etc. Because the power of the denominator factor is 1, integral over c z plus 2, numerator no change, but denominator is a second degree factor. Already two z values, two roots are there. So this quadratic factor can be written as product of two linear factors. Z minus of first factor is minus 1 plus j into second factor z minus of minus 1 minus j. Can I write like this? Whenever a quadratic equation having two roots, alpha, beta, then that quadratic equation can be written as x minus alpha into x minus beta, provided x square coefficient is 1. Here z square coefficient is 1, dz. So write the generally to compare to write this integral as Cauchy integral formulas notation, which factor in the denominator, which factor to write in the numerator, how you decide. So write the factor corresponding to a singular point inside the curve in the denominator, other factors in the numerator. Okay. So this minus 1 plus j, we already verified this is inside C. So write this factor, keep this factor only in the denominator, then shift this second factor into the numerator. So this can be expressed as z plus 2 divided by z minus of minus 1 plus j, put it in bracket, whole divided by, oh, sorry, this is numerator. We have to put this first factor in the denominator. This is shift into numerator. So this is better to write minus 1 minus j. Now this denominator is z minus of minus 1 plus j dj. Now this looks like Cauchy's integral formula, where numerator fraction is denoted by f of z, denominator factor is denoted by z minus a. So this point is a. Now what is your answer? 2 pi I into f of z. Okay. So this is nothing but 2 pi I. In place of I, we have to multiply j. We have to write j. F of j. J means what is this singular point? Minus 1 plus this is the singular point. A is the singular point. Okay. So once if I denote A in Cauchy integral theorem or Cauchy integral formula, that point lies inside the curve. Okay. So using Cauchy's integral formula. So this, how do you find f of minus 1 plus j in this numerator fraction f of z? Put z is equal to minus 1 plus j. So this is 2 pi j multiplied by, now numerator is z plus 2. In place of z, put minus 1 plus j. Minus 1 plus j plus 2 divided by, in denominator factor z minus of minus 1 plus j, there put z is equal to okay. So in the denominator of the function f of z is z minus of minus 1 minus z. In that put z is equal to minus 1 plus j. So minus 1 plus j minus of, already there is minus 1 minus j. See this one. This is f of z. F of minus 1 plus z. How do you get? In this f of z, wherever z, put z is equal to minus 1 plus j. So minus 1 plus j plus 2. This is okay. In denominator also z minus 1 plus j and the remaining as easily. Okay. Because this is your a. Now this simplifies to 2 pi j numerator 1 plus j divided by denominator. Minus 1 plus 1 got cancelled. This is 2j. 2j, the prefactor 2j cancel, pre-multiplication factor. You will be getting pi times 1 plus j. Okay. So this is the answer. Accordingly, the option is B. This is the end of the question. The next question is, let the sets of eigenvalues and eigenvectors of a matrix B set lambda k such that 1 less than or equal to k less than or equal to n, and vk set of all vk such that 1 less than or equal to k less than or equal to n respectively. For any invertible matrix B, the sets of eigenvalues and eigenvectors of the matrix A, where B is equal to P inverse A into P respectively are. Four options given. This is from engineering mathematics from the topic linear algebra, subtopic eigenvalues, eigenvectors, properties. The solution is, so first observation, B is the P inverse into A into P. P is inverse exist, invertible matrix. Okay. So already B matrix, eigenvalues, lambda 1, lambda 2, so on, lambda n, which is an n cross n matrix. Eigenvectors usually denoted by capital X. In place of capital X, they have denoted by V symbol. So that V1, V2, V3, so on, Vn are the n eigenvectors correspondingly to the n eigenvalues lambda 1, lambda 2, so on, lambda n of the matrix B given. Okay. See. Just according to the properties of eigenvalues, eigenvectors, B and matrix A and B matrix are called similar matrices. Similar matrices having same eigenvalues. Okay, so that's why the eigenvalues of the matrix A are nothing but lambda k, set of all lambda k 1 less than or equal to k less than or equal to n. Here, by the definition of similarity matrices, similar matrices, A and B are similar matrices. A matrix B is said to be similar to another matrix A, square matrix A of order n, if there exists a non-singular matrix B such that B is equal to P inverse into A into P. So therefore, by properties of eigenvalues and eigenvectors, comma, 1, first point, A and B is nothing but P inverse into A into P, have same eigenvalues number 2. If usually X, capital X, is an eigenvector of matrix B is nothing but P inverse into A into P, then Px is corresponding eigenvector, an eigenvector of matrix A. This is the properties in eigenvalues and eigenvectors, one of the properties. Okay. Px is an eigenvector of A. So therefore, from these 2 points, we can conclude lambda k for 1 less than or equal to k less than or equal to n. That is lambda 1, lambda 2, so on, lambda n, the set. Okay, are the eigenvalues of matrix A. So in all last three options we have lambda k, but p into x, I denoted eigenvector by x. He has given eigenvector of the matrix B. That is, B has eigenvector notation for the matrix B. The eigenvector denoted by Vk. So for the corresponding eigenvector of the matrix A is P into Vk, because if x is eigenvector of B, then P into x. In place of x, he has given Vk. Okay. And P into Vk or new symbol also. New symbol. If you compare with alpha, beta, gamma, Greek letter, this is new k or Vk. P into Vk for 1 less than or equal to k less than or equal to n. Okay. This is also I can write in set. Or the eigen vectors of the matrix A. Okay. Of the matrix A. Or if you are not satisfied in exam, if you do not remember this result, don't worry. If A is the square matrix having eigenvalue lambda and the corresponding eigenvector x, then the relationship between these three is Ax equal to lambda x. So to prove that a vector x is an eigenvector of the matrix A corresponding to lambda, it is enough to show that Ax equal to lambda x. Okay. So I can do that also. Or alternative method C. Consider we want to prove P into Vk is an eigenvector of the matrix A. It is enough to show that A into P into Vk is equal to lambda k into P into Vk. Okay. So A into P matrix into Vk is the eigenvector. Vk is an eigenvector of the matrix B. Okay. Now we have to get P inverse AP. So there is P already. I can write this is I into A into P into Vk. Identity matrix, where I is the identity matrix. I into A is nothing but A. And this again I can write I. P into P inverse. A matrix into its inverse is nothing but identity matrix into A into P into Vk. And this term I can write P inverse into A into P is already given B. Okay. So this is P into B into Vk. Okay. Now what is Vk? Is an eigenvector of lambda. So this is P into lambda k into Vk. Since B has E vector, that is eigenvector, Vk corresponding to E value lambda k. Therefore, the relationship between matrix eigenvalue eigenvector is B into Vk is equal to lambda k into Vk. Am I correct? Ax equal to lambda x definition. So now this I can write lambda k into P into Vk. Now just observe the left hand side and right hand side relation. A into, say this is x. We got lambda into x. So therefore P into Vk is an eigen E vector of matrix A for k values. That is 1, 2, so on n. That is 1 less than or equal to k less than or equal to n. So finally P into Vk, lambda k is the set. This set is eigenvalues and this set is eigenvectors. So accordingly, the answer is option C. This is the end of the question. The question is the value of the line integral p to q z square dx plus 3y square dy plus 2xz dz along the straight line joining the points p112 and q231 is four options given. This is from engineering mathematics from the topic vector calculus. And the solution is line integral. So either you express this f bar dot dr bar. Actually, this is f bar dot dr bar. Okay, already given in Cartesian form. So express this integrand in variable separable form or exact differential, that is derivative of some function, or one variable terms only depending on the curve equation. Okay, so I can write directly this is integral p to q z square dx 3y square dy plus 2xz dz. Already curve is given straight line joining these 2 points. Straight line joining 2 points, you know that x1, y1, z1, x2, y2, z, z2, x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Using that, you will be getting this expression into one variable terms. That is one method. Second method is, for this problem is there. I can express this integrand, that is z square dx plus 3y square dy plus 2xz dz as derivative of some function using standard exact differentials. Once you express like that, that derivative and this integration got cancelled and just substituting upper limit, lower limit by normal integration method. Let us see. Here this term is variable separable. This is y terms multiplied by dy. This is one of the variable separable. Z and x are not variable separable terms. So, but I can write UV rule using standard exact differentials. So, this is equal to integral p to q z square into derivative of x. Dx means derivative of x. There is no pre-multiplying x terms. So, write as it is like that. Don't simplify this z square dx. But now I am writing this third term after z square dx because these are two variables z and x terms. This 2xz is containing derivative of z. So its pre-multiplication 2z is there. Using exact differential, 2z dz can be written as derivative of z square. So this is x into derivative of z square. The remaining 3y square dy, even though is variable separable, we can write derivative of some function. 3y square is the derivative of y cube. So 3y square dy, I can write derivative of y cube. Now this first two terms looks like z square into x derivative plus x into z square derivative. UV rule, product rule differentiation. So this is p to q derivative of x into z square. And this is already derivative of y cube. Just see. this term, this term. Okay. Now, so this can written as P2Q derivative of sum of the derivatives can be written as derivative of some functions. Derivative of the sum of the functions. And this d derivative integration got cancelled. You will be getting simply xz square plus yq. Substituting upper and lower limit q. Q point is 2, 3, 1. P point is 1, 1, 2. Now put x2, y3, z1, that is upper limit. So this is 2 times 3 square 9 plus, sorry, z value 1. 1 square is 1. 1 plus y cube, 3 cube is 27. So this is upper limit simplification minus. Now putting lower limit x value 1, y value 1, z value 2. 1 into 2 square 4 plus y cube 1. So this is 29 minus 5, 24. Okay. So there is an answer. Option B. Alternative method I am telling you. You can try later. So C is straight line. C means curve. Okay. PQ implies equation is x minus x1. This is first point x1 y1 z1, second point x2 y2 z2. 2 minus 1, y minus 1 by 3 minus 1, z minus 2 by 1 minus 2. So this can be written as x minus 1 by 1, y minus 1 by 2, z minus 2 by minus 1. So expressing yz in terms of x, that is one method. We using that will take more simplification. That means you may get silly mistakes also from these two y value in terms of x, and from first and last term find z value in terms of x. So sometimes that procedure will make difficult. It is not difficult. Will take more calculations, more number of steps. It is better to take this is t in play. All these three equal to t. So from this, find xyz in terms of t, third variable, fourth variable. So I want to express, I told you, all are in terms of one variable terms. So t plus 1, y value, 2t plus 1, z value, minus t plus 2. Okay. So, and t limits 0 to 1. Just in any of these x, t, y, t, z, t, substitute x lower limit, x upper limit, or y limits or z limits, you will be getting corresponding t limits 0 to 1. And dx, dy, dz, you know, dx is dt, dy is equal to 2 dt, dz is minus dt. So therefore, you will be getting the finally again 24. So the answer is 24. This is end of the question. The question is, let X be an n cross n real matrix, real column matrix, vector, with length L is equal to square root of X transpose X. The trace of the matrix P is equal to X into X transpose is. 4 options given. This is from engineering mathematics, from the topic linear algebra, subtopic basics. The solution is, here X is a column matrix. Column vector means column matrix. N cross 1. N rows, 1 column. So sometimes we have to consider a particular case, that is 2 cross 1 matrix, 3 cross 1 column matrix. N cross 1 means we don't know n value. Okay, I can take x is equal to some x1, x2, so on, xn, that is n elements, which looks like problem is lengthy in that case, general case. So better to take particular case, that is 2 elements column matrix, 3 elements column matrix maximum only, because we finally want one of the option is the answer. they don't want the procedure in general case. Okay, because of 2 marks, 1 marks also. Let us consider particular case. Consider a 2 cross 1, that is n is equal to 2. Column vector x is equal to x1, x2. Two elements. 2 into 1 means two elements are not. So first row, second row, only one column. Instead of considering n cross 1. If I consider, okay, you can take x is equal to x1, x2, so on, xn, n elements also, n components also, column vector. But finally, you will be getting the answer. We'll take more number of steps. It is not, it doesn't mean that more number of steps. The calculation takes more time. That is. No. What is X transpose? Row vector. X1, X2. So there is P matrix X into X transpose. There is length is equal to X transpose into X. X transpose into X. That is row matrix X1, X2 multiplied with column matrix X1, X2. So finally this gives one element, single element. This is also called length of a vector definition, square of the length of the vector, X transpose into X. So length of a vector X is denoted by norm X symbol and is defined as square root of X transpose into X. So this is first row into this column, X1 into X1, X1 square plus X2 into X2, X2 square. Okay. So, you know this length of a vector, square root of. Okay. So, which implies L is equal to root over X transpose into X is nothing but root over X1 square plus X2 square. Okay. Now, only one option C containing L, remaining options L square. Let us see. Now, matrix P is defined as X into X transpose. X means column matrix, X1, X2. X transpose row matrix, X1, X2. So, which give, this is 2 into 1, 1 into 2, 2 cross 2 matrix you will be getting. If I consider n cross 1 column matrix, you will be getting n cross n square matrix P. Time consuming and confusing also. You will be getting confusion also if you take general case n cross 1 matrix. Total n into n square elements. It is writing that n cross n matrix also takes more time. So first row into first column, x1 into x1, x1 square. First row into second column, x1, x2. Second row of this column matrix multiplied by first column of the second matrix. X2, x1 is nothing but x1, x2. Second row multiplied by second column. Only each row column containing, that is here, one element. Okay. X2 square. Now this is a 2 cross 2 matrix. Now trace of a square matrix. This is a square matrix or not? Trace of a square matrix is defined as sum of the diagonal elements, principal diagonal elements, which implies trace of P, matrix P is, these are the two diagonal elements. Add these two elements, x1 square plus x2 square. Trace of a square matrix A is defined as sum of the principal diagonal element, SUM sum. So, which is nothing but L square. L is already, we got square root of x1 square plus x2 square. This is length of x. Okay. This is the length of vector x. Okay. Now this becomes L square. Okay. So finally we got trace of P is L square. Understood or not? Okay. Hmm. So the answer is option A. Accordingly, this is end of the question. So this is not related to mathematics question. Now the next question is, the value of the integral double integral over r xy dx dy over the region r given in the figure is rounded off to the nearest integer. This is a numeric question. So this is a plane region given. It is a square. Let us check. This side line y is equal to x, and this is y is equal to minus x, y is equal to x plus 2, y is equal to minus x plus 2, bounded by four straight lines. The region r is a square region. Okay. So this is from engineering mathematics from the topic multiple integrals, and the solution is, so let us denote this shaded region is R. R is the shaded region. Now, to evaluate the double integral, either you take first vertical strip or horizontal strip. If I take horizontal strip at any location here, if I take here, then this is lower limit, sorry, left side, y is equal to x is equal to minus y lower limit, x is equal to y upper limit. If I take here, x is equal to y minus 2 is lower limit, x is equal to y plus 2, 2 minus y is the upper limit. So limits changes. If I take different locations, the horizontal strip. So where you have the changes, where the change occurs, if I take here the strip, no problem. If I take here, if I take here, if I take here, now if I take here from this part, the location changes, that is the strip changes, limits changes. Okay. So solution. This is O, this is A, this is B, this is I want to take. So once again, I am drawing the diagram. X axis, this is Y axis. Now this is 1 unit. This is 2 units. Join this. Join this. This is the region or this is the origin. Let us denote this point A. This is already given to. This is B and this is C. So joining C and A from that above, the if I take horizontal strip, limits changes. So first of all, the curves. So this curve is y is equal to minus x plus 2. I want to take horizontal strip, or you can take vertical strip dividing the region into two equal parts also. I mean two parts, which implies x value 2 minus y, and this curve equation is y is equal to x plus 2. From this, x is equal to y minus 2, and this part is y is equal to minus x. From this, I can write x is equal to minus y, and this curve equation is y is equal to x. So for all the four boundaries, he has given already y in terms of x, but I want to express x in terms of y. Implies x is equal to y. So this is an indication by dotted lines. So by this, the red dotted lines, this region divided into two parts, R1 and R2. Okay. R1, and this part is R2. Okay. So now let O, A, B, C, O. be the boundary of the given region R. Okay. Where O is equal to 0, comma 0. Now divide region R into two subregions R1 whose boundary is OACO and R2 second region subregion whose boundary is ABCA with horizontal strips. That is considering with horizontal strips. Horizontal strips. Okay. So in this region R1, R2 take horizontal strip. So here I am taking, this is the strip, horizontal strip, and here this is the horizontal strip. The strip name is P2Q. Here also P2, horizontal strip is denoted by PQ, horizontal strips PQ. Okay. Or you can denote P1, Q1, P2, Q2. Now we have to find the limits. That means this given double integral R is now expressed as double integral over R1 plus double integral over R2. So in each subregion, we have to find the corresponding x and y limits because horizontal strip means x limits are functions of y. That's why I expressed each curve equation like this, and y limits are constants. So in R1, y limits are 0 to 1. This is 1. This. And in R2, y limits are 1 to 2. Okay. So in R1 region, comma, x limits minus y to y. Y limits, constant limits, 0 to 1. Am I correct? This is 0 to 1. Y limits. Y direction, y is equal to some number means it is a horizontal line. So when in this horizontal strip, it is moving from origin to one number 1 only. That is CA line only. Slide that strip from origin to CA. Next in R2, slide or move the strip, horizontal strip from this dotted line to number 2. So 1 to 2 y limits. Or you can find the boundary extreme points, point of intersection A, B, C by solving the corresponding two equations. From that way also you can get the y limits in each region R1 and R2. Okay. Next in R2, x limits y minus 2 to 2 minus y. Y limits 1 to 2. See, this part lies between y is equal to 1 and y is equal to 2. Y is constant limits. And in R1, is lies between the boundaries y constant limits, y is equal to 1 and y is equal to 0. So this is x value y minus 2 and this is x value 2 minus 1. So y minus 2 is lower limit, 2 minus y is upper limit of x. Okay. So therefore, double integral over R xy dx dy is equal to double integral R1 plus double integral over R2. So in R1, constant limits y is equal to 0 to 1, keep outside, x limits minus y to y, first integrating with respect to x by keeping y constant. Okay. Dx into dy plus in the second integrals y is equal to 1 to 2, keeping outside, x limits y minus 2 to 2 minus y, again y constant with respect to x, first integrating, then with respect to y. Okay. So this is constant, y limits constant, CYNST means constant, this is constant. Okay. Now, so y is equal to 0 to 1, y into x integration with respect to x is x square by 2, or x power 1 is odd function, this is 0. minus y to y, and then dy plus y is equal to 1 to 2. So if I take here minus common, minus 2 minus y, this is also odd function, 0. Okay, y into x square by 2. In one variable integrations, if you compare, both are with respect to x odd functions. So minus a to a f of x dx is 0. Or you can do by direct integration, y minus 2 to y plus 2. Okay, dy, upper limit and lower limit. So 0 to 1, y by 2 into y square minus y square. In place of x, put upper limit and lower limit. 1 to 2, 1 by 2, that is y by 2 into, in place of x, put a upper limit y plus 2. Sorry, 2 minus y. You can write 2 minus y. Hmm. So minus y plus 2 whole square plus of y minus 2 whole square dy. Both simplifies to 0 plus 0 is equal to 0. So the value is 0. Answer is 0. This is the end of the question. So now I'm going to discuss WE paper, electrical and electronics engineering. Now I'm going to discuss WE Gate 2023 Engineering Mathematics questions, Electrical and Electronics Engineering stream, Mathematics questions. WE Gate 2023. Now, the first question. For a given vector W is equal to 1, 2, 3 transpose of a row matrix, comma, the vector normal to the plane defined by W transpose X is equal to 1 is. Four options given. This is from engineering mathematics from the topic vector calculus. The solution is, so vectors can be represented in IJK regular notation, directed line segment, or row vector, column vector notation. So we know that plane equation generally a first degree equation in xy plane, xyz coordinates. So that's why 3D coordinates point is given. So here w given but x value not given. So you can take x is equal to vector x is equal to xyz. So w transpose becomes column vector. Uh, no, sorry. W is already column vector. W transpose is row vector. So that x I can take column vector given vector W is equal to 1, 2, 3 column vector. Let x is equal to row vector x, y, z, three variable. Okay. The plane equation is W transpose x is equal to 1, which is nothing but 1, 2, 3. So x better to take column vector. This is transpose. Okay. 1, 2, 3 into x, y, z. Row matrix multiplied by column matrix means you will be getting only one element. First row into this first column. X into 1, x, 2 into y, 2y, plus 3 into z is equal to 1. So which is a first degree equation in xyz. PQ means equation in x comma y comma z variables. So finally I converted into Cartesian form. Okay. So for this now, I mean plane is a scalar field. For this scalar function, which is a function of x, y, z, scalar function, we have to find normal vector. Normal vector means gradient. Gradient is always represents a vector normal to the given surface, where the surface is here plane surface. Normal vector means gradient only. Geometrically, gradient of a function phi is a vector normal to the surface phi only. Phi of x comma y comma z. Okay. So let phi of x comma y comma z is equal to x plus 2y plus 3z minus 1. Okay. Then normal vector. Bring all the terms to one side. That is your scalar function phi of x comma y comma z. Normal vector to the plane is gradient phi. That is del phi. Because it is three variables. I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. So with respect to x partially 1, with respect to y partial derivative 2, with respect to z partial derivative is 3. So this is I cap into 1 plus j cap into 2 plus k cap into 3. This is the normal vector. That is I cap plus 2j cap plus 3k cap. Okay. So this is very, very important step. Without taking x, we cannot find the plane equation. This is plane equation, first degree equation. These are the highlighted terms. And this is phi function, scalar function, how to take. Bring all the terms from the given equation to one side. Now, they are asking at the for a given vector normal to the plane. So every vector can be represented either a row matrix or column matrix. Okay, please refer that books. This is can be written as either 1, 2, 3 or row matrix 1, 2, 3. Therefore, required normal vector or vector normal to the plane is 1, 2, 3. That is 1, 2, 3 transpose. I can write column vector can be written as transpose of a row vector. So accordingly, the option is D. This is the end of the question. In the figure, the question is, in the figure, the vectors u and v are related as AU is equal to V by a transformation matrix A. The correct choice of A is, here diagrammatic representation is there, U, V is horizontal, U is slope. 4 options ABCD given, matrices, 2 by 2 matrices. This is from engineering mathematics from the topic linear algebra, subtopic basics. The solution is joining origin to V, that is the vector V bar. I can write 5i plus 0 into j because it is a two-dimensional. Okay, and this is u vector is 4i plus 3j. From the figure, this is vectors u and v related as comma vector u is nothing but 5 times I cap 0 times j cap, where I, j are respectively the unit vectors along horizontal vertical axis. Here v vector is already lies on horizontal axis. Okay, when v vector, oh sorry, this is v, horizontal vector is v, slope vector is u vector. Okay, vector u is equal to joining 0 0 and 4 comma 3, that is the vector u bar, joining 0 0 and 5 0 point, that is the vector v bar. So 4 I cap plus 3 j cap. Now what is the matrix? We don't know the matrix. So some problems the solution is obtained by depending on options. By using options we can get the answer. Okay, so verify A is equal to V. A is the required answer, which is one of the option with the given options. Whichever satisfies the option, that is the required matrix A. Okay, so option A. Let us take the option A, matrix A. How much? 4 by 5, 3 by 5, minus 3 by 5, which is an orthogonal matrix, 4 by 5, implies A into U. That is 4 by 5, 3 by 5, minus 3 by 5, 4 by 5 into V. U. U means how much? 4, 3. 4i plus 3j can be written as either column matrix or row matrix. Every matrix, I mean every vector can be represented as a three-dimensional point or two-dimensional point depending on ijk. That point can be written as again row matrix or column matrix. 4, 3. Okay. So this first row into this column, second row into this column. So how much? This is equal to 4 by 5 into 4, 16 by 5 plus 3 by 5 into 3, 9 by 5. This is the first element of the A into U matrix. Now, second row into first column. Minus 3 by 4, minus 3 by 5 into 4, minus 12 by 5, plus 4 by 5 into 3, plus 12 by 5. So, this simplifies to 25 by 5 means 5. This is both are same opposite signs 0. Again, this 5 0 can be written as pi by vector. Every matrix can be represented in column matrix or row matrix. I mean every vector. So this is nothing but V. So therefore option A. Okay, this is option A is the answer. The first option only we have verified. We got. Similarly, you can cross check at home. B, C, D. Any one of these satisfied or not. Okay. They ask which the correct choice of A. The correct means one answer only. If you have more than one answer, that is a multiple choice question. Anyhow, this is a one option is the answer because the correct choice. Okay. So accordingly, option A is the answer. This is end of the question. Next. The question is in the following differential equation, comma, the numerically obtained value of y of t at t is equal to 1 is rounded off to two decimal places. dy by dt is equal to e power minus at divided by 2 plus alpha t. Alpha value 0.01 and y of 0 is equal to 0. This is from engineering mathematics from the topic numerical methods, subtopic numerical solution to ordinary differential equation. The solution is, so this is the differential equation in place of x variable, t variable. So t is independent variable. Okay, dE. So from this dE, the right hand side already it is standard form dy by dt. The right side is a function of ty variables. Okay, when x and y variables, the right side of the differential equation is denoted by f of x comma y. If t and y variables, the right side is denoted by f of t comma y. So differential equation dE is the short form of differential equation. Is dy by dx is equal to e to the power minus at divided by 2 plus at. A or alpha you can write. Okay, I think it is alpha notation. Okay, this is alpha. It's a printing mistake. This is alpha t. This is also okay. So better to write here also alpha notation. Alpha. So where alpha given? How much? I mean, t is equal to 1 rounded off to alpha. This is given. Okay, where alpha is equal to 0.01. No, y of 0 is equal to 0 given. Okay, from this so this is your function of t comma y variables, and this is y naught t naught value implies f of t comma y e power minus alpha t divided by 2 plus alpha t comma y naught 0 and t naught also 0. We have to take the step size. They are asking y of t at t is equal to 1. Okay, take h is equal to 0.5. Now finally we are finding y of 1 is equal to question mark. That is y of t at t is equal to 1 means substituting in y of t is equal to 1, you will be getting y of 1, that is going to find. Now this is the data given. Which method? Method is not mentioned. I can apply forward Euler's method by explicit Euler's method or forward Euler's method. Explicit Euler's method. So this is nothing but forward. comma y1 by putting that is yi plus 1 is equal to yi plus h times f of ti comma yi. There you put I is equal to 0. Y1 is equal to y0 plus h times function of t0 comma y0. In place of x variable we have t variable. Y0 value 0, h value point y 0.5. Function of t naught value 0, y naught value 0. How do you find f of 0 comma 0? In this function of t comma y, put t 0 y 0. So this is 0.5 into e power 0 divided by 2 plus 0. So 1 by 2 is 0.5. 0.5 into 0.5, 0.25 you will be getting. Okay. This is y1 value. What is y1 value of y at t1? What is t1 value of y at t0 plus it? This is 0.5. Since just like x1 here, t1 is equal to t0 plus h. So by this first iteration, we got y of 0.5. That is the y value, the value of y at t is equal to 0.5. But we have to find the value of y at t is equal to 1. So one more step we have to find. One more iteration. That is one more approximation value, solution y. And y2 is equal to y0 plus h times f of t1 comma y1. In general forward Euler's method, putting I is equal to 1, you will be getting y2 is equal to y1 plus h times function of t1 comma y1. What is y1? 0.25. H value 0.5 into function of t1 0.5, y1 0.25. This is 0.25 plus 0.5 into. So in this function of t comma y, put t value 0.5, alpha value already given 0.01. So you will be getting e power 0.5 into 0.01 minus 0.005 divided by 2 point, sorry, 005. So this simplifies to this y2 means y of t2. Since t2 value means t1 plus h, which is simplifies to 1. So therefore y of 1 is equal to 0.25 plus 0.5 into 0.496, that is, so simplifies to 0.498, approximately 0.50 up to 2 decimal places asked. Is the value of y of t at t is equal to 1. Okay. So this is the solution 0.50. This is end of the question. Next. The question is 3 points in the xy plane are minus 1 comma 0.8 comma 0 comma 2.2 and 1 comma 2.8. The value of the slope of the best fit straight line in the least square sense is round up to 2 decimal places. This is from engineering mathematics, from the topic probability and statistics, that is regression, correlation and regression subtopic. The solution is, so line of best fit in the least square sense means taking that line equation as y on x, that is y is equal to ax plus b or a plus bx, or the linear regression line of y on x is y minus y bar is equal to byx into x minus x bar. Any one of these you can use. By using the given 3 data points, x values, y values, you will get the answer. So first of all, given data. This is first x1, y1, x2, y2, x3, y3. X versus y, which I want to put in two boxes. This is the data. Okay. So what are x values? -1, 0, 1. What are y values correspondingly? 0.8, 2.2, 2.8. That is three pairs of data. Three. This is bivariate population, two-dimensional. So n is equal to 3 points. Okay. Now the best fit straight line in least square sense is y is equal to ax plus b, or you can write a plus bx. Implies this is say equation 1. So they are asking slope. Am I correct or not? Value of the slope. Slope is nothing but this is a straight line equation in two variables x and y. Slope of the straight line looks like y is equal to mx plus c. This is your slope. Okay. So slope means we are going to find here x coefficient, that is a value only. So implies slope of equation 1 is a. Okay. How do you find this a? Or you can use to find a and b, the normal equations. Two normal equations are there. The normal equations of 1 are first, for the first equation, taking both sides, summation, that is sigma y is equal to a times sigma x plus b into sigma 1 means n into b. Okay, this is equation 2. And multiply x on both sides, then operate sigma on both sides. So sigma x into y is equal to a times sigma x square plus b times sigma x. This is equation 3. Okay, now look at the data. X, y, we have to find product x into y to find that x. Okay, and x square. Now this data, x values -1, 0, 1. Corresponding y values 0.8, 2.2, 2.8. X into y -0.8, 0, 2.8. X square 1, 0, 1. So adding all these, you will be getting sigma x means sum of x values 0. Sum of these three values denoted by sigma y. This is 5.8. Okay. Next, this is summation of all products xy, sigma xy. This simplifies to 2. Summation x square simplifies to 2. Okay. Now, therefore, substituting all these in 2 and 3. Therefore, equations 2 and 3 becomes 5.8 is equal to 3b. Where I put this 8.8. N value 3. A value we don't know. Sigma x value 0. So from this first equation we will be getting b. sigma y value 5.8 implies b is equal to approximately 1.93 and into in second equation again sigma x 0 b 0. You will be getting directly from third equation sigma x, not required to solve second equation. Okay, directly third equation because we want a only. 2 is equal to 2a implies a is equal to 1. Therefore, required slope is 1. This step is not doesn't require, but if they ask what are the values of a and b, that is y-intercept or slope, whatever it may be, then you have to find b value as well. B is the y-intercept of the straight line. Okay, so or what we can take, this is the best fit. The best fit can also be taken as y minus y bar is equal to vyx into x minus x bar. What are x bar, y bar? X bar means 1 by n sigma x, that is average of x values. Y bar means 1 by n average of y values. Vyx means covariance of sigma square x. Covariance of xy formula I am giving 1 by n summation xy minus x bar into y bar. Standard deviation variance square of x, square of sigma means variance of x variable, 1 by n sigma x square minus x bar whole square. You can do this method also. So the answer is 1, required slope is 1. This is end of the question. Now the question is, consider the following equation in a 2D real space, mod x1 power p plus mod x2 power p is equal to 1 for p greater than 0. Which of the following statements is or true? 4 options ABCD given. This is from engineering mathematics from the topic calculus basics, coordinate geometry, miscellaneous type question. And the solution is, let us obtain the solution by options method. Take one by one options. So given real space, is mod x1 power p plus mod x2 power p is equal to 1, comma p greater than 0. What is option A given? P is equal to 2, comma. Let us take this 1, equation 1, comma 1 implies 1 gives mod x1 square plus mod x2 square is equal to 1. So this looks like circle equation. X square plus y square is equal to 1, which is a circle having center is equal to 0, 0, radius, origin, comma, radius is equal to 1. Okay. So the area implies area is pi r square. That means pi into 1 square is equal to pi. Area of a circle, pi into radius square. Now, so this is also correct. Uh, when p tends to infinity, this does not represent a curve. Okay, comma, 1 will not a curve, proper curve, will not form a x power infinity, y power infinity. Is it a curve? Will not form a proper curve. Now see, p tends to 0. That is not also a curve. 1 plus 1 is not equal to 1. 1 will not form a proper curve. Okay. Now, when I put in option D p is equal to 1, in option D, when p is equal to 1, comma 1 gives mod x1 plus mod x2 is equal to 1. This is actually, mod plus or minus x1 plus or minus x2. It represents four straight lines which is bounded by a square. That is which is this equation represents square bounded by. In our 12th standard, we have learned 11th and 12th standard, which is a, if you remember, applications of integration areas. This is a competitive exam question in JE mains. This type of question, okay, asked in after 12th standard. Calculus part is a square formed, that is bounded by the lines. First, both are positive. Let us take x1 plus x2 is equal to 1. Next, first one is negative, second one is positive. So that x minus x1 plus x2 is equal to 1. First one positive, second one negative, or both are negative, is equal to 1. And the fourth one is first one positive, second one negative. Just like first quadrant, both are positive. This is second quadrant, first x negative, y positive. Compare like that. Both xy negative. Third quadrant, both first one x positive, y variable negative. Fourth quadrant. Okay. You know that diagram. All this. So, and moreover, intercept form of a straight line equation. X by a plus y by b is straight line. ST means straight line equation EQ in intercept form. That is, A is x-intercept, B is y-intercept. When a straight line cuts the x-axis at a point A, then the distance between origin and A is called x-intercept, usually denoted by small a. The same straight line cuts the y-axis at a point B, then the distance between origin and B is called y-intercept, that is usually denoted by small b. Now, the square x-axis, that means x means x1 variable, vertical axis taking x2, horizontal axis x1. Sorry, this is origin, and the four boundaries, 1 unit, this is 1 unit, this is 1 unit, and this is 1 unit. Joining these boundaries, okay, so this point is 1 0, this point is 0 1, this point is minus 1 0, and this point is 0 comma minus 1. Okay, so this equation is x1 by 1 plus x2 by 1, that is x1 plus x2 is equal to 1, and this equation is joining these two, x-intercept minus 1 here, don't take negative part, so length is positive only, so minus x1 plus x2 is equal to 1. This is third quadrant, intercept form of a straight line, both are negative, minus x1 minus x2 is equal to 1. This is fourth part, fourth quadrant. X1 positive, x1 negative, x2 negative is equal to 1. Okay. So what is area of a square? Square of its length. Side square. That is a square. Or diagonal square by 2. D is the distance between, that is two opposite vertices, which is the diagonal. So let A is equal to length of each side. So which is getting this one, not this one, anything. 1 minus 0 whole square plus 0 minus 1 whole square is equal to root 2. Therefore, area of square is a square or d square by d, comma d is equal to length of diagonal, which is nothing but 2. So here, finally, area of square root 2 square 1 minus of this is diagonal square 4. Distance between minus 1 0 0 1 1 0. You will be getting this is the diagonal, this is the diagonal 4. So finally, which one correct? Is also correct. A, D correct. So the answer is options A and D. This is end of the question. We'll continue tomorrow. Thank you.